This is Ratatouille, a TUI framework in Rust that is replacing the tui-rs project as the successor. If you don't know what a TUI is, this is a TUI. This is running in my terminal, and it has a bunch of graphs, a bunch of data being generated in this case. We've got spark lines and gauges and all sorts of other widgets like charts. If I go up and down with the up and down arrows, you can see the list on the left-hand side here is increasing or decreasing depending on whether I'm going down or up. And if I go left and right, it will change to tabs, which you can see at the top here. We've got tab 0, tab 1, which is a map setup, and tab 3 or 2, depending on how you want to index it. So if you want to build in-depth experiences in your terminal, or you just enjoy spending more time in your terminal emulator, Ratatouille is for you. Now, I wanted to see how easy it was to integrate Ratatouille into my own applications. And I have a example app here that is trying to do some audio processing using CPAL. Now, my end goal with this is that it will go from CPAL to WGPU, but before I have the WGPU backend ready, I wanted to see if it could render the decibel level of my microphone in the terminal, which you are seeing right here. This is a spark line for which 0 is the bottom, so louder sounds make the bars go smaller because I'm just running .absolute value on the F32s, which are all negative. So decibels come in, -100 is super low volume, you probably wouldn't hear it, while like -5 is pretty high, and they're just reversed on this chart. So lower is higher and higher is lower. That's why for the most part, when I'm talking, you can see these huge valleys because I'm actually talking and it's going in and recording. Whereas when I stop talking, which I often don't show in videos, you see these higher blocks. And Ratatouille has turned out pretty nice. So if I create a new terminal here, and I sort of drag this up to be kind of, okay, sit in the top left corner or something, I'm showing enough data or trying to show enough data that this will still have data to show along the entire width of the screen. And you can see that it's fairly responsive to the size of my terminal. Now, I'm not sure if this will come through on the video, but it is a little choppy on my side. So I can stop this and poll on 50 milliseconds instead of 250. And now when I'm polling every 50 milliseconds, you can see all the data throwing by much faster. It's a little bit less chunky. And I've totally arbitrarily chosen the parameters of this kind of demo. So I'm just going to put it back to 250 and I'm going to let it be a little chunky because it doesn't really matter to me. So two things I noticed from using Ratatouille. The first is that the hard part is not really setting up the terminal UI. The UI comes down to basically you have to get your data in somehow, and then you have to set up the little component in whatever layout you want it to be in. So this is a UI component. It takes some frame. There's some state, which I've wrapped in an arc mutex because I'm actually reading this in actively from my microphone that I'm using to record this video live. And that's all getting stored in some app state. So I'm doing mutex locking so I can modify the vec with the decibel value. And then when I go to actually render it, I take that decibel value by taking the lock again, iterating, reversing the iterator, taking about 300 of the samples. Well, actually not the samples, but that's not important. Absolute valuing them, which is why we get a graph that looks like this, and then collecting them into a new vec. So in this case, I've set the layout constraints to a min of 0, but we can also set them to, say, a length of 3. So if I include both of these components, you can kind of see how that ends up laying out on screen. We've got a constraint with a length of 3, which the 3 refers to the number of lines here. You can see if I highlight this, there's 1 line, 2 line, and then the 3rd line with the title at the top. And then we've got this thing that kind of fills up the rest of the space. I'm going to leave it with the constraint with a min of 0 because I kind of like it being the full width of the terminal right now for this video in particular. So we've got our spark line. We define the block with the title. In this case, we've got borders on the left and the right. You can see those white lines. So there's some styling options, which you can very easily discover in the docs. And of course, you can set colors. And finally, you take the frame, you render a widget, which is the spark line with the layout it's supposed to have. And that's really it. There's a bunch of widgets. You put them on the screen. You can organize them in different ways. You've got tabs, you've got graphs, you've got other widgets like gauges. And there is a little bit of boilerplate to set up and boilerplate to tear down. In this case, we're using the cross-term backend, which we'll cover in a second. We get standard in, we get standard out, we enable raw mode. Raw mode comes from cross-term. Execute also comes from cross-term. So you can see that the backend that we're using matters a lot for the setup and the teardown. And we create this new terminal with the background. The terminal comes from Ratatouille. And then once we're done doing whatever we're doing, because, we don't want to run this TUI forever, we then have to disable raw mode, execute some command for cross-term, and then show the cursor again. So in practice, the way this plays out is you kind of have your setup code, you have your app running, and then you restore the terminal to its previous state. So I'm going to leave this decibel visualizer up at the top just because I find it a little bit fun for this video. And let's dig a little bit into what Ratatouille actually is. So first of all, Ratatouille is a library for building the rich TUI experiences, TUI, as opposed to GUI for GUI or graphical user interface. This is a fork of the TUI project, tui-rs, and is, as far as I can tell, the successor to it at this point. It's the most active fork with the most sort of people behind it at the moment. Adding Ratatouille itself is fairly easy, but bear in mind that this is not all you need to do. You do also need to add cross-term or a different backend. So in this case, there are 3 options listed in the README: cross-term, termian, and termwiz. I will say that cross-term being the default makes sense to me, specifically because new shell, the shell that I use in all of my videos, also uses cross-term. So in general, you're supposed to rebuild the entire UI every time you render it. This, they mention, might not be the best for high performance UI visualizations. So they do try to minimize sort of the performance impact of that, even though in general, it tends to not matter. So for me, for example, I'm rendering quite a bit of audio data. This is a sample of 44,100 samples per second that is batched into groups of 1,024, if I remember correctly, that I am then taking the max decibel value of for that sampling. So I'm getting about 44, we'll say, samples per second, or 44 decibel levels per second that I need to render out here. And that's working just fine. You can remember that I could speed this up if I wanted to, but I'm actually limiting it myself to 250 milliseconds instead of something that might show more of the data more continuously. The Hello World app for Ratatouille is fairly straightforward. It is also partially where I got some of the code for setup and teardown. I don't write too many TUIs, so I don't know how often you'd actually want to modify this code, but definitely for getting started, it feels a little bit like this boilerplate should be encapsulated somewhere. There are sort of 3 relevant areas for the README if you're trying to figure out what you can actually show on screen or what already exists out there. There's the built-in widgets. You can see Sparkline right here from what we saw. That is, the graph right above here is a Sparkline. And you've also got tabs and tables and other things, which are really nice because tables, as you might not know, are usually complicated to implement. So it's always nice to have some of those more complicated widgets just readily available. The widgets, of course, come each with their own examples, as well as the demo example we saw in the beginning. I've found from looking at the examples that they're written in an extremely generic way, so keep that in mind when you're going through this. In this case, it supports all 3 of the backends because it's the demo. But if you go look at, say, the Sparkline demo, you'll have to deal with sort of some trait constraints because they do write this to be applicable to any backend, even though you might only be using cross-term or termwiz or whatever. There are, of course, third-party libraries that already exist, many of which were built for the original TUI library that this is a fork of. For me, one of the most interesting ones here is the sort of text area-like widget shown here that allows you to type in a little bit more than maybe other things would. You could imagine that this would be really useful if you were building, say, your own document system or your own note-taking system. So you could run your terminal command and pop up whatever you wanted to edit, type something really quickly without a full editor bootstrapping, and then quit out. And then I also highly encourage you to go check out the apps using Ratatouille. There are some fun ones like Battleship or even Minesweeper, but there are also clients for Spotify or Twitch, debugging tools, and more. So this should give you a number of ideas for building your own TUI applications if you're still a little bit confused as to why somebody would build a TUI. So that's all there is for today. I actually really enjoyed trying to work with Ratatouille, and the problems that I ran into were not related to Ratatouille at all when I was setting up this demo of the Sparkline on top. The stuff I ran into personally was more that, say, WGPU uses async APIs and CPAL doesn't use async APIs, but it spawns its own thread in certain cases, but doesn't spawn its own thread in other cases because usually audio is done in a dedicated hardware or device or whatever. It's not super important, but I found setting up the actual UI for the text user interface easy, or perhaps easier than setting up the data to get actually into the UI itself, especially when that data is coming from real world systems that all handle data or accessing each of the systems in different ways. So I hope you enjoyed this look at Ratatouille. I'll see you in the next one. Have a great rest of your day.